Here we go with lesson 2 of module 15. So we're going to look at samples and surveys. We're going to be looking at how data is collected today. So we're going to look at data and determine if a sample of data is quantitative or qualitative, univariate or bivariate, random, systematic or stratified, fair or biased. So we're going to take a look at all those things today. When collecting data, you need to make sure your methods are fair and that you accurately represent the results. You can collect data in two ways. You can do it in measurements or categories. So quantitative means basically numerical, has units and can be measured and compared numerically. Age, weight, time are three very common examples. You can also do qualitative data, so qualities, or describes a category, cannot be measured. So hair color, attitude, zip code. You might be like, well, zip code's numbers. You're right, zip code is numbers, but they're not measurements. They're just random numbers. That makes them qualitative. Okay, so we're going to take a look at a couple of these examples to determine whether things are qualitative or quantitative. So movies. These are not numerical. It's qualitative. Number of students in different schools who take Spanish. You can measure the numbers. This is numerical. Therefore, it's quantitative. Basketball jersey numbers. This one's tricky. It's actually qualitative. The basketball jersey numbers are not measurements. They're just numbers. Okay, you're not measuring anything, therefore it is qualitative. Okay, the kind of data you are working with determines the type of graph you use to display the data. A set of data that uses one variable is called univariate. Two variables is bivariate. So, the atomic weights of elements in the periodic table. The only variable here is atomic weights, meaning this is univariate. The height and weight of football players on the team, that's two variables, therefore it's bivariate. Statisticians collect information about specific groups of objects or people. The entire group that you want information about is called a population. When a population is too large to survey, statisticians survey a part of it to find characteristics of the whole. The part of the survey, the part that is surveyed is called the sample. If the whole population is a group of 100 people, which of the following would be a good number in the sample? So if you have 100 people that you're trying to make a conclusion about, how many people do you need to make it a good sample? Well, 10 would not be enough. 30 is probably not enough. 50 is better. 90 is the best. If you can get 90, that's really good. It's probably hard to get 90. 50 would be okay. For half the people, that would be okay. There's not a certain number. It's just kind of if you're making a determination on America with multiple hundreds of millions of people, 5 people would not be enough, but 100 million people might be enough. 10 million people might be enough. Okay, so it's understanding that idea. There are 3 sampling methods we need to talk about: random, systematic, and stratified. Okay, random is when you survey a population using a process where each item in the population has an equal probability of being chosen. Think about people being drawn out of a hat, so names being drawn out of a hat. It's completely random. Everybody has a chance. Systematic is you select a number n at random, then survey every nth person. So n is a number. So let's say we just randomly roll a dice and you get 1 through 5. So I'm going to select, or 1 through 6, and I get a 5. I'm going to pick every 5th person. That's a systematic way of getting a random sample. The last one's a stratified. So separate a population into smaller groups, each with a certain characteristic, then survey at random within each group. So an easy one to see this would be separating a high school into 4 groups by grade. So freshmen, sophomores, juniors, and seniors. You survey a random sample from each grade. All right, you want to find out how many video games students at your school play in a month. Okay, so think about the population there. These are students at your school. You want to get a sample because you can't get everyone at your school. You interview every 10th teenager you see at a mall. What sampling method are you using? You're sampling every 10th person, so that's a systematic. It's systematic because you're doing every 10th person. Is this a good sample? Think about it. Hopefully you see that it's not a great sample because you're asking people at a mall who may not be going to your school. And then you'd be including people who don't go to your school, which could mess up the data. Okay? A survey question has bias when it contains assumptions that may or may not be true. Bias can influence opinion and can make one answer seem better than another. Survey questions must be carefully worded to avoid bias. So a reporter wants to find out what kind of movies are most popular with local residents. The reporter asks, do you prefer exciting action movies or boring documentaries? Is the question biased? Think about it. Hopefully you see the issues. The question is biased because the words exciting and boring make action films sound more interesting than documentaries. People are going to be drawn to those adjectives, exciting or boring. Okay, and it's going to make people lean one way or the other, probably. Okay, so biased sampling means one or more parts of the population being sampled are being favored over other parts. Fair sampling is representative of the entire population, gives each thing an equal chance of being chosen. So, 4 examples here. A group of students is to be selected, and the height of each student is to be measured to find the average height of a student in a specific high school. Are the following samples fair or unfair? Why or why not? So if I sampled the basketball team, hopefully you realize it's probably not going to be fair because basketball players typically are a little taller, right? So that's going to bring the average up over what the average height is. The first 5 students to enter each classroom. That's pretty fair. It's random. Tall students do not have an advantage over short students to get to class first. All have a chance to be chosen. All freshman girls are chosen. Well, that's biased. Only girls have a chance to be chosen. Boys don't have a chance at all. And then D is very similar. Every 10th boy in a list of all boys in the school. That's a systematic sample, but it's still biased because it's only boys. Okay. So to avoid bias, you want to try to represent the whole population. You randomly select subjects so that each member of the population has a chance of being randomly selected. You don't overrepresent or underrepresent a certain group in the population. Hard to do, but need to try to make that happen. So that concludes lesson 2 of this module.